In this video, I will give you an introduction to inverses involving parabolas, which I think is one of the trickier ones to end up working out the equation of the inverse. And so let me give you a cool trick to get you through it. So step one, when I'm working out the inverse of this equation, x squared minus 2x minus 8, I just swap the x's and the y's. So that's pretty chilled. And then my goal is to try to get y by itself. And so I take the minus 8 across. And at this stage, you're heading on the right trajectory, but it feels a little bit awkward to have a y squared and a y. And so how do you end up getting to a place where you just have y by itself? And the trick is to complete the square. And so what I'm going to do, the way that I do completing the square, is I take half of the, in this case, the y term, just that number, the coefficient, half of that number in a bracket squared. I always minus, and then what I magically introduced, I magically, in a sense, am cancelling. Okay, let me just explain that again. So if this was the case, and you said, how do you do completing the square? It's half of the y coefficient squared, and then what you magically introduced, you magically minus. Don't forget the squared as well. This just becomes a number. It becomes minus 1 on this side, and when I take minus 1 across, it's plus 1. Now I'm starting to get closer. So if I square root both sides, so I must write plus minus. When I square root, I end up with just y minus 1, and then all I need to do is take the plus 1 across. Be careful to just have that plus 1 being outside of the square root so that it doesn't get locked inside. And again, that is the answer. I'm done with my inverse, but I like to just write it. If I started off with gx equals this, I like to finish as a final answer as g minus 1x in inverse notation equals this. And so if you're ever doing a question, let's say the question begins and you have this. If you see a surd equation in graphs, in inverses, then you know that this graph, this surd graph, is the inverse of a parabola. So that's just helpful to know and distinguish the link. And here's where it all comes from. And so if I said to you now, you've done it mathematically, please can you draw it? Then what you would do is, if it's me, I just draw the original graph. And so the y-intercept of the original graph is minus 8. So let me pop that in there. If I want the x-intercepts, I let y be 0, and I'm just factorizing. And I get 4 and minus 2. So there's the 4 and the minus 2. Turning point, you can use derivative equals 0 if you've done calculus yet. If you don't know what I'm talking about, you can just go old school, minus b over 2a. And once I've subbed that in, I get an answer of 1. That means that the turning point x value is 1. How do I get a y value? Whenever you're missing a value, you just sub in. So I would just sub 1 back into the original equation, and that then spat out minus 9. So the green graph is my original, it's drawn, and if I feel like this is giving me a bit of a headache to try to draw this graph, I can take what I've got as my original graph and just swap everything, because that's what you do with inverses, you swap the x's and the y's. So if the x-intercepts were minus 2 and 4, now the y-intercepts are minus 2 and 4. If the y-intercept of the original is minus 8, now the x-intercept of the original is minus 8. If the turning point was 1 minus 9, you just swap those numbers. Be careful not to make it minus 1, 9, which some people do. Just swap the numbers, so it's minus 9, 1, and there's your new turning point, and you can basically play dot to dot from there to see what happens. Quite a common question to follow from this, which I won't do in this video, is they'll say, is the inverse a function? And no, it's not, because it doesn't pass the vertical line test. It cuts twice, so it's not a function. Then they'll ask you to restrict it so that it becomes a function. And I will talk more about that in future videos, restricting the inverse to make it a function. The last thing to say just on this video is that if you wanted, you could have, instead of doing completing the square from this step here, you could have just worked out the turning point, and you would have used the same formula, but it would be pertaining to y, and then you can put it back into the turning point formula equation, and if you were missing a letter, you could sub in a point. The other thing to say is, what is a? It's whatever's in front of the original y squared, and so in this case I can see that it's 1, so I could have just put 1 here, and that's another way just to help you avoid completing the square. But hopefully me having gone through it just and given another example here made it a little bit easier for you to understand how you can use completing the square. If you found this video useful, please like it, subscribe to our channel, and share it with your friends. Thanks.